I'm Dave Austin. In this segment, we're going to learn how to open and use our Molecular Visions molecular model set. We'll first open the kit, get a little familiar with its contents. Then we'll build a molecule of methane and then cyclohexane. Let's get started. When you first open the kit, you're going to see that there are two strips, one strip of black and one multicolored strip. We're going to focus on the black strip. These are the carbons that you'll use. You can pull out each strip, and it's connected to a rubber piece. Behind the top strip, you'll see several white balls. These are hydrogen. We would think of these as oxygen, and the blue could be nitrogen, or perhaps even a halogen, if you will. So let's take out the bottom strip and learn how to construct a carbon. It's a little confusing at first because it doesn't look like a tetrahedral molecule. But as we pull the first few segments out, you'll see that we can actually attach two of them together. Hold them in your hands like this. Bring them together so that the segments actually match up, and then click them into place. When you first start to use the kit, you'll notice that it's a little difficult to snap them into place. You'll also notice that they snap into place twice. You put them together, and then you give them a quick tug, like that. That's how I like to assemble these. So let's assemble a few so that we can build the molecule that we're interested in. Suppose we want to build methane. What we would do at this point is we would select 4 hydrogen molecules. Now you'll notice that the molecules have a very thin side and a very fat side. And there's a reason for this. Because with each tetrahedral carbon, you'll see that we have 2 sticks that are thin and 2 sticks that are fat. The reason this is like this is because we need to connect them together at some point. And so we connect them by putting a thin stick into the fat stick. But in order to build methane, we need to put an atom on the end. To build the first hydrogen, I take the thin stick and snap it into place. I take the other thin stick and snap it into place. At this point, I now take my thick end and bring it in. And you'll notice that it's very difficult to get this in. This is because the kit hasn't been used. As you use the kit more, you'll see that the pieces come together much more efficiently. Now, I have a minor problem at this point, because it doesn't look to me like these bonds are the same. So what you need to do is pull out the hydrogens on the thin piece so that you can get a nice tetrahedron. Let's try that one more time. Thin. And thick. Now you'll notice here that we're out of hydrogen, and this is a limitation of the kit. We could use any other color that we're interested in, but when we're trying to build molecules with stereochemistry, this might be a challenge. Now we're going to build cyclohexane. To do this, we need a few more atoms, so let's build them. I grab another set from the plastic strip, snap them together, give them my second snap, and I build as I go. It's a good idea for you to build your atoms along with me. And if you need to stop the tape, just stop it and build what you need to build. At this point, I now have 5. I need one more. Got to get that extra snap. Now I have 6 carbons. I'm going to take the hydrogens off and save them for later. Now I start to assemble the carbon atoms. You see we have a thin and a thick piece, and these snap together like this. I then add the next one, and the next one, and the next one. Finally, I put my last piece in place. I have 6 carbon atoms, which I now link together. This is the most challenging part of building cyclohexane. This cyclohexane looks nothing like the cyclohexane you've seen on the screen or the cyclohexane we worked on in class. So how do you actually get the conformation of this model into the proper conformation? Remember that cyclohexane in its most stable conformation is trans, is a chair. So what we want to do is bend the molecule in such a way that gives us an up and a down segment. You'll see here now that we have a straight line and a straight line. I'm going to tilt it a little bit toward you, and you can see that this carbon is going up and this carbon is going down relative to this plane, this imaginary plane that I've made. Now what we do is we actually want to check our structure and make sure that it's right. The way I do this is I actually eye down this line and make sure that when I do, that this axial position is 180 degrees to this axial position. And if it is, I know that I've built the chair properly. Let me quickly take a look at my model and make sure it's correct. I do this for every carbon-carbon bond that I've constructed. It's sort of like doing a visual Newman. Now when I set cyclohexane down, 3 points should touch the table, like so. And it should look completely symmetric. Now if I want to build a structure off of cyclohexane, I have the option of putting another carbon atom on. And I'm going to build it like this. As I mentioned earlier, a limitation of this model set is that there aren't enough hydrogens to put hydrogens at each position. But you can see that when the sticks come out, we can envision that there is a hydrogen at each of these positions. This is what we would call axial cyclohexane. And we know that axial cyclohexane is a less stable conformer. So how do we actually go from axial cyclohexane to equatorial cyclohexane? We do what we call a ring flip. To do the ring flip with your model kit, bend down at the central position. That puts the methyl in an equatorial position. Now we have a boat. The boat is not stable. We need to get the chair. So we bend up in the other position to give us the opposite chair. Now don't trust that you've done this correctly. Do your Newman trick and eye down every atom and make sure that each structure looks like a proper Newman. And there we have a stable equatorial methyl hydrogen. So what we've done is we've learned how to open our model set, identify the particular components that we need to build molecules. We built the methane, we built the cyclohexane, we learned how to actually vary the conformations of the cyclohexane and adopt the most stable conformation.